So starting in section 7.3, we're learning a process called completing the square. This is 7.3.1 because it's the first of two parts of 7.3, okay? Completing the square is a procedure used to convert a quadratic equation from general form to vertex form. You can see that I've rewritten the general form, y equals ax squared plus bx plus c, and rewritten the vertex form, y equals a times x minus h squared plus k, where hk would be the coordinates of the vertex of the parabola, right? Now on last night's homework, you had problems that started in vertex form, and you had to convert them to general form. Completing the square will give you a means of starting in general form and going to vertex form. So we're going the exact opposite direction. How? By completing the square. So here is our first look at completing the square. So pay attention. X squared minus 14x plus 3. This is a quadratic expression in the general form. We're going to convert it to vertex form by completing the square. The first thing that we do when completing the square is we group the variable terms in parentheses. The next step is the most important step, okay? We take half of the coefficient of the x term and square it. So half of 14 is 7. 7 squared is 49. And we're going to take that 49 and we are going to add it on to what's in parentheses. And we're going to subtract it on to the end of our expression. The reason we're doing this is because if we add on 49 and then subtract 49, we're doing nothing to the expression, right? Because 49 minus 49 is 0, and we are always allowed to add 0 onto anything because it doesn't change it. The next step is to factor what's inside the parentheses. So this is going back to factoring quadratics. Imagine this being a problem all by itself. If I erased this and I said factor x squared minus 14x plus 49, that's what the next step. That's what we have to do next. Okay? Oh, there we go. Okay. So let's do it. All right. We're going to go through this in detail. We set up the parentheses for our two binomials. Now, the way that we talked about it in the first semester is you look at the second sign of the quadratic. If it's positive, then whatever the first sign is, right there, it goes in both sets of parentheses. So this would be a minus and a minus. X squared factors into x times x. 49, factors of 49 that will combine to give me 14. Well, that would be 7 and 7. Now we know that x minus 7 times x minus 7 is the same thing as x minus 7 squared. So let's write it like that. And don't forget it. Oh, somehow I lost my plus 3 here. Don't forget that we're going to have the plus 3 minus 49 on the end. So let's combine those because they're both constants. Plus 3 minus 49 is negative 46. We've now successfully changed our quadratic expression from the general form to the vertex form, where the coordinates of the vertex, hk, would be 7, negative 46. second example here, 2x squared minus 6x plus 1. This is already in the general form. We are being asked to convert it to vertex form. We do that by completing the square. This problem is going to be a little bit different because of that 2 right there. Okay? We have to pay special attention to how that 2 changes things. All right, here we go. We'll start the same way we started before by putting our variable terms in parentheses. Next, look inside the parentheses. We have 2x squared minus 6x. If you can factor something out, a number, then you have to before doing the completing the square. For example, 2 goes into 2 and 2 goes into 6. So we have to factor the 2 out. So we have 2x squared minus 3x. And then plus 1 still on the end. Now we take half of the coefficient of the x term and we square it. So half of 3 is 1.5. 1.5 squared, if you need a calculator, use a calculator, is 2.25. Okay. So we have 2 times x squared minus 3x plus 2.25. And then we have the plus 1. Now, here's where things change again. We added 2.25 right there in green, or at least it looks that way. But we actually didn't add 2.25 because this 2 out in front is being multiplied by that 2.25. So really what we added on was 4.5 because 2 times 2.25 is 4.5. So that's what we added on to that part. Then that's what we have to add on to the end. Or, excuse me, subtract onto the end. So minus 4.5. So we are still adding 4.5 and subtracting 4.5, which is like adding 0, which we're always allowed to do. So the next step now is to factor what's inside the parentheses. Now, instead of going through the specifics of the factoring, we know what this should factor into already, because we took half of this 3 and squared it to get that number. So let's use that number. Half of 3 is the 1.5, so let's just do x minus the 1.5 and square the whole thing. And now I'll take plus 1 minus 4.5 and get minus 3.5 on the end. And there's our quadratic in vertex form. Last example, this one is only slightly different because it has y equals in it. That y equals means nothing to us. It does make it an equation as opposed to an expression, but in terms of completing the square, it means nothing. So let's just go through our process. We group our variable terms together. The coefficient of the squared term is already a 1. So there's no reason to factor anything out. We don't have to do that. We are now ready to take half of 18, which is 9, and square it, which is 81. And we're going to add it here. And subtract it here. Now we factor what's in parentheses, and again, we don't have to go through all the steps of factoring because we know it was the half of 18, the 9, that got us the 81, so let's just say x minus 9 squared. And 100 minus 81 is 19. And there's our quadratic equation in vertex form.